Mhm. All right, welcome to our project called Climate Change, Agriculture, and Justice in the Iberian Peninsula by Harrison, Jack, and Henry. This is Henry speaking, and first I'm going to be talking about the overall effects of climate change on the Iberian Peninsula. We have the expansion of the North Hadley Cell northwards, increase in pressure over the Iberian Peninsula, and droughts, heat waves, and depressed harvests. Um, and so the expansion of the North Hadley Cell is a huge reason, the primary reason why the Iberian Peninsula is being affected so heavily by climate change. The Iberian Peninsula is becoming hotter and drier because of the expansion of the edge of the North Hadley Cell northwards. Because of raised levels of greenhouse gases, making the ITCZ, or the Intertropical Convergence Zone, bigger. More warm wind is getting blown upwards and outwards towards the poles. Um, because of this, the North Hadley Cell now reaches up to southern Europe, including the Iberian Peninsula. Um, this change in location of the edge of the North Hadley Cell is making the Iberian Peninsula an area of high pressure. When the air from the North Hadley Cell descends on the peninsula, the descending warm air destroys clouds and increases the pressure on the surface. This has several effects. The destruction of clouds allows more shortwave radiation to reach the surface, heating the area. In addition, the increased heat causes more evaporation, and the warmer air is more able to take in that water, so the area as a whole gets much drier. These effects are causing the most two common effects of climate change in this area: droughts and heat waves. So as you can see, over the last 74 years, as a study discovered, average temperature in the area increased by 0.5 degrees Celsius, and average pressure increased over those 74 years, 0.7 HPA. Normally, the Mediterranean area has wet and cold winters, and this process has been drying those winters and amplifying the already hot and dry summers. This causes effects like the 2003 heat wave in Europe, except it's happening more significantly and over a longer time frame with the Iberian Peninsula, resulting in more droughts, heat waves, and depressed harvests. Oh, and this is a graph I have to represent that change in number of drought events per 30 years. So as you can see, using the key, the Iberian Peninsula and parts of Italy and other parts of Europe, of Southern Europe, are by far the most vulnerable to droughts in the past 30 years. But the Iberian Peninsula, being the largest landmass at this latitude, um, is most affected by this change and is in great danger of desertification.
So, as for the effects of climate change on the agriculture of Iberia, wheat and barley are two of the largest crops for Spain, and climate change poses a serious risk for their future. The ways in which climate change is impacting these crops is through an increase in temperatures, droughts and water scarcity due to changes in rainfall patterns, and an increase in pests and diseases, which all contribute to a change in the annual crop yields for Spain. So the increase in temperature is altering the growing seasons as winters are becoming shorter and crops are now forced to mature earlier, which impacts the annual crop yield. The warmer temperatures call for occasional heat waves, which directly damage crops as they're sensitive to heat. So the change in rainfall is limiting the crop yields as it is becoming less dependable, while more intense rainfall events are occurring. Lower rainfall, higher rates of evaporation, and less snowfall lead to more droughts, while on the other hand, the increase in frequency of these intense rainfall events are seriously impacting the crops as they are flooding the field, causing soil erosion and the loss of the topsoil. As for the increase in pests and diseases, the warmer and damper conditions are more desirable for these pests, which leads to an increased presence and only further damages the crops. So annually, there's a 6% loss of agricultural production based on the current change in temperature each year. Now, if temperature increases by 2 degrees Celsius, that annual yield could decrease by up to 15%. Currently, 75% of Spain's surface area is at risk of desertification, and the agri-food sector accounts for 5.8% of Spain's national GDP, which is at risk of being lost due to climate change. Now, some figures representing this data. So as for the first visual on the left, over cluster one, both wheat and barley mid-of-century distributions are similar to the historical yields for negative anomalies, as fewer extreme losses are projected. In contrast, positive anomalies in the future differ significantly from the ones estimated for the historical climate, with a tendency to larger positive extremes. There is a shift to the right of the ECDFs representing the mid-of-century, which becomes larger with greater yield. With increasing warming, the yield distribution for mid-of-century RCP 8.5 shows the largest shift to the right. As for cluster 2, this shows different results than those of cluster 1. Here, for both grains, the analysis reveals a shift to the left of the ECDFs representing the mid-of-century period, meaning higher probabilities of having yield losses independently of the anomaly sign. Differences between historical and mid-of-century are more severe than in cluster 1. The probability of having barley yield anomaly lower than -2 in the historical climate amounts to about 4%, and anomalies smaller than -4 are never identified. While in the RCP 8.5 future climate, the probability of having barley yield anomalies lower than -2 reaches more than 30%, and anomaly losses may exceed -7. So as for the second visual on the bottom right, this is a representation of a year-long study to identify any agricultural drought trends using soil moisture anomalies in SWDI, which is severe weather data inventory, with the aim of identifying whether any temporary patterns exist. So there's a marked pattern that includes 10 months with negative trends and 2 months with positive trends. A clear predominance of negative trends was obtained from April to January, and a positive trend was obtained from February to March.
All right. Take the computer over here. Sweet. Okay. Well, I like to stay optimistic in general. Things are clearly going to get worse and worse before they get better for farmers all over the world, especially for vineyards in places like the Iberian Peninsula. For a long time, winemaking and grape farming have been ingrained in the culture of Spain and Portugal, especially in the rural farm-centered communities. It's safe to say that the rural people of Spain and Portugal depend on wine, not just economically, but also culturally. Unfortunately, the expansion of the North Hadley Cell northward and an increase in pressure over the Iberian Peninsula, along with other factors, has led Spain's overall temperature to increase and its precipitation to decrease to the point where droughts are becoming more and more common. This puts massive strains on all crops, especially grapes, which are yielding far less than usual because of it. And even what they do yield has been lower quality than expected. For example, farmers I've been testing grapes, and over the past, especially like 20 years alone, grapes' acidity and size and other such factors have been getting worse and worse with smaller grapes and more acidity, which makes obviously the wine they produce less quality. This has essentially put many vineyards on a countdown to the point where they can no longer feasibly produce anything. Scientists and farmers are well aware of this fact, but the only solution that scientists have been able to suggest to the farmers is either installing large irrigation systems or moving the vineyards to higher elevated areas where it stays cooler for longer. Both of these solutions are unfortunately extremely expensive and only a temporary slowdown to the more significant issue at hand, the climate as a whole. The scientific articles I found on climate change in the Iberian Peninsula, in regards to vineyards specifically, also contain some terrific graphs that depict temperature change in the region or predicted temperature change until 2100, and what that means for the vineyards in the area. Every single graph shows that the Iberian Peninsula is going to have this coming temperature/climate change the worst. For example, in this graph, it only shows Spain, but you can infer that Portugal would be very similar. It is a graph of temperature change and the expected, essentially the livability for vineyards and grape growth in the region. And what you would want to see is between 1,500 and 3,000, which is the green, yellow, sometimes orangish area. But as you can see, by the time 2100, the best predictions, only very northwestern Spain will be able to produce or be safe enough to really produce any grapes, while the rest of Spain is going to be pretty unlivable for them. And in the worst case scenario, virtually the entirety of Spain will have no grapes be able to grow in it unless they are heavily irrigated and essentially, yeah, heavily irrigated. In this next graph, it is it is showing the Hughlin index for 1950 all over the Mediterranean and Europe. And as you can see, even though this was a time before we were feeling the big effects of climate change, Spain is still definitely one of the warmer climates and for Europe. And the graph next to it shows the linear trend, which is the red line up, showing that this is only going to get worse, which means that Spain, which is already on the hotter side compared to all these other European countries, is again only going to get hotter and hotter. On my final graph, it is depicting, let me see it. The final graph on my section of my presentation also shows how much each region/vineyard is going to have to adapt to climate change to quote unquote stay alive. The Iberian Peninsula is one of the top regions that absolutely has to adapt to keep producing grapes or wine. It is a bit blurry, but if you look in the very top of the image, it shows a zoomed in photo of the Mediterranean and the nations around it. And it is clearly showing Spain mostly red with some orange, meaning that the majority of Spain is going to have to adapt massively to be able to save any of their grape population. Overall, the future of grape and wine production in Iberia looks grim, especially regarding the survivability of local grape varieties. The increase in droughts and temperature will force winemakers to adapt or lose their vineyards to climate change. Hopefully, in the near future, a better, more permanent solution can be found for these farmers.